Good day, welcome to this next lesson. In this lesson, we will be going through an exam paper question covering electricity and electric circuits.
It says an 8 ohm resistor, a light bulb, and a rheostat are placed. Okay, 8 ohm resistor, a light bulb, and a rheostat. That thing there with the line through it, that's a rheostat. And what's a rheostat? It's a variable resistor. It's like a dimmer switch. We can change the electricity going through it by changing the amount of resistance. Okay, and they are connected to an 8.4 volt battery with an internal resistance of 0.4 ohms. Shown in the diagram, the power of the light bulb is 8.1 W watts. The rheostat is changed until the ammeter shows a reading of 1,5 amps when the switch is closed. So we mess with this until we get a current of 1.5. Now it says calculate the resistance of the light bulb. Okay, well that's pretty easy because we have the power and we've got the current. Okay, so we can use the equation P is equal to I squared R. Therefore, R is going to be P over I squared, which is going to be 8,1 over 1,5 all squared. And I just need my calculator for that. So it's going to be 8.1 divided by bracket, divided by bracket 1.5 bracket squared equals 3,6. 3,6 what? Ohms. Guys, please remember your units. Okay, so that's the resistance, 3,6. Now it says calculate the resistance of the rheostat when the reading on the ammeter is 1.5 amps. In other words, we need to work out the total resistance, external resistance of the circuit so that we can work out this resistance. So we've got EMF is equal to I big R plus little r, right? The EMF we got is 8.4, okay? The current we're told is 1,5 times by the total external resistance, which is what we're trying to work out, plus the little internal resistance of 0,4. So therefore we can solve for big R by going 8,4 divided by 1,5 minus 0,4 is equal to R. So let's pop that into our calculators. So we've got 8.4 divided by 1.5 equals minus 0,4 equals, so that's 5,2. So total external resistance is 5,2 ohms, right? But that is made up of this 3,6 and those two that are in parallel. So we can subtract 3,6 from this to find out what the parallel combination are made up of. So that is minus 3.6 is going to be 1.6. That leaves us 1.6 ohms. So therefore, we can say that 1 over 1,6 is going to be equal to 1 over the rheostat plus 1 over 8. So therefore we can say that 1 over 1,6 minus 1 over 8 is equal to 1 over the rheostat. So we are going to put that in our calculators again. So we've got 1 over 1.6 minus 1 over 8, close bracket, equals a half. So therefore we know that 1 over 2 equals 1 over R, the resistance of the rheostat. Therefore the resistance of the rheostat is 2 ohms. Ta-da! So that's 2 ohms there. Sure, nice bit of work that you had to do for your 6 marks. So you had to think it through and think about what you needed to work out before we could actually work it out. So basically the first thing we need to do is work out what the total external resistance was from the EMF equation and then work it out back slowly to work out what this was. Okay, so we've done that. It now says the rheostat is changed, so the resistance of the rheostat increases dramatically. So we're increasing this dramatically, okay? How will the following readings be influenced? Write down only increases, decreases, or remains the same. Okay, so what is going to happen to the total resistance of the circuit? Okay, well, think about it. Let's say, for example, I've got 1 over 2 plus 1 over 8, okay? D is equal to 1 over r, right? So do you agree 1 over r is going to be common denominator of 8? That is going to be 4 plus 1. So therefore we've got that 1 over r is going to be 5 over 8. Therefore r is 8 over 5, which is 1 comma something. Okay, now let's say we dramatically increase the resistance to say 10 ohms. So now we've got 1 over 10 plus 1 over 8. Common denominator is 80. We've got 8 plus 10, which is 18 over 80, is 1 over r. Therefore, r is going to be 80 divided by 18. So if we pop that in our calculators, you're going to go 80 divided by 18, which is going to be 4.44 ... So do you see that basically by increasing this resistance, what are we doing? We're increasing the total resistance in the circuit. So therefore the total resistance in the circuit is going to increase. What is going to happen to the EMF of the battery? Well, if we increase the EMF of the battery, is going to remain the same, because the EMF of the battery is the maximum amount of voltage that the battery can supply the circuit at any time. So therefore the EMF doesn't change. But what happens to the reading on voltmeter V1? V1 is the amount of energy it takes to get this around the circuit. And if we increase the resistance, what's going to happen? We have to increase the voltage to get that around the circuit. So V1 is going to increase.